So I don't want to give you the statistics the marks per subject because of time. Because I know we have a lot. I had prepared a lot of marks allocated per subject, per topic from those years, but let me talk briefly about how can we eliminate D and E grades. We have what we call D eliminators. D and E eliminators. I've coined that one, and we have the form. We have the word D eliminators. DE eliminators. Now, I don't expect a student who is seated here to get even this grade that we call D. I know there are some teachers who have this notion that you cannot get more than D. They call you that you are a poor conductor of chemistry. When they look at you and this one cannot make it in chemistry. He cannot even get a good grade they call you a very poor conductor of chemistry. I want to demystify that. I want to say that with confidently that there's no student here who is seated here who can get this grade E and D. And I want to give you a simple way in which you can actually eliminate this D and E grade. When I'm marking chemistry paper 1, I want to say this. For the last 14 years or 15 years, I've been marking chemistry paper 1. We look at how the students are performed, and we are told as examiners, now, can you tell us, now you've been marking this paper, tell us where you would want an A to start from. And I want to say for sure, when we are marking these papers, the student who actually managed to get 30 and above, 30 and above, they are less than 30%. Shocking. Out of the 950,000 students, because chemistry is actually done virtually by everybody. All schools, chemistry is like it's compulsory. So out of these 950,000 students who sit for the chemistry paper, when we look at what they have actually gotten in that chemistry paper 1, you will discover that those who get 30 and above, they are less than 30%. Meaning that a good 70% of the students get 30 and below. But my question is this. Why should he? Because when you talk about 30 and below, they fall under that category of D+, downwards up to E. A good number of them. My question that I normally ask myself, why do these students get these grades and they miss some of these lucrative courses? The question is very simple. Number 1, content-wise, they have what we call gaps. Do you know the essence for us for coming for this wonderful program that we have in our institution? Is to bridge the gaps that you have. You know, when you are taught in a group, 70 in a class, the teacher wants to rush very fast to finish the syllabus. And those ones who are actually average students or below average students, they are left behind to actually follow others. And by doing that, they find that we have a lot of gaps. Gaps in the sense that content-wise, they don't have the nitty-gritty things that are required in chemistry. So that when the questions are set, they have no idea. They actually end up blank. They cannot be able to answer question correctly. And that is why this program that we have had for the last 3 weeks is very important, so that we can be able to bridge the gaps to enable you go beyond grade C. Actually, I want to say this one without any doubt. If you have been able to attend our program for the last 3 weeks, the least grade that we expect when you perform badly in chemistry is a C+. C+. And if you are here for this mentorship program, you are now moving beyond C+. And you know, when you get chemistry C+, your general grade is C+ and above. You qualify for the university. You will discover that the students who get maths that Honorable Shaban is actually going to actually discuss this afternoon together with chemistry that I'm actually handling, and our director has handled biology. If you are able to get C+ in those 3 subjects, your mean grade cannot be less than C+. That one you can take to the bank. So let me say this. For you to be able to eliminate D and E, number 1, you must have content in the periodic table. The periodic table takes 25 marks. And I've already emphasized, under the periodic table, we have combined the 4 topics. That is the structure of the atom and the periodic table. We have, chemical families. We have the structure and bonding. And then we have the trends. All right. Now, I was saying that you must have the concept of the periodic table with you. And by the way, this periodic table that people talk about, it is not even, very difficult, because you're talking about elements which are arranged in various groups. And in these groups, what defines a particular group is the number of electrons that are found in the outermost energy level, right? Like, for example, group 1. All group 1 elements, the atoms, they have 1 electron in the outermost energy level. So they are placed under group 1. Group 2, they have 2 electrons. The atoms have 2 electrons in the outermost energy level. And then you have the groups, of course, all the way to, group 8. And then when you look at these elements, there is a way in which they react. Metals in group 1, group 2, group 3, right? They can react with nonmetals. And in this case, when they react, they use what we call the valency. What is the valency? When you talk about valency, somebody, what is the valency? Yes. The combining power of an element, right? And it is defined by the number of electrons which an atom can either lose or gain. Because when we talk about formation of a bond, it is formed when atoms, right, share electrons, or the one actually donates, another one receives, right? So when you talk about this, ensure that you know how to write the chemical formula of various compounds. And when you talk about chemical formula of a particular compound, in chemistry, ladies and gentlemen, we summarize various reactions using what we call chemical equations. And in a chemical equation, of course, we have the compounds that must be written correctly. They must have the correct formula in each one of them. And you cannot be able to write the correct formula of a particular compound if you don't know its valence, the valency of the element that forms that particular compound. And that is why it's very important that you need to actually have this one at the back of it. You see, when I'm dissecting this, when we are writing chemical formula of a particular compound, or we are writing the chemical equation, the knowledge that we get from periodicity, right? Periodicity here, I'm talking about, the structure of the atom. And the atoms, of course, they react by either losing or gaining, right? That one should be at your fingertips. So have that in mind. The periodic table, structured bonding, the trends across the elements that form period 3, that is also very important. Now, salts. Any student who wants to eliminate D and E, you must ensure that you have this concept of salt at your fingertips. When I started teaching, when I started interacting, for those of us who have been in our physical classes, when we've been coming to Nairobi for the physical classes, for the case of Form 3, the last class I had with Form 3, I dissected this topic of salt. And we gave you handouts. you can go and share with your colleagues in other schools, share, and then look at those examples. Even Form 4, this topic of salt, we have already done it. I gave you the handout that had questions set from 1989 to where we are on salt. And we did some good work with Madam Esther going through the topics, going through the questions and dissecting some of the gray areas in those. So I want you to be grounded in this salt so that you can be able to pass. So please, this salt takes 30 to 50 marks in both paper 1, paper 2, and paper 3. Now, industrial chemistry, the chemistry of various compounds, carbon and its compounds, we have sulfur and its compounds, we have nitrogen and its compounds, and then we have chlorine and its compounds. The gases, I want to let you know this afternoon. We have a total of 18 gases. Now let me say this one with a lot of authority. As you go to your respective schools, go and list down the gases, the 18 gases that we have. Those ones that are there in our secondary syllabus. And in these gases, as you list them down, I want you to look at these areas. If you can write this one down. Because I'm talking about these, and the gases are actually tested. Number 1, you must ensure that you know the laboratory preparation of these gases. Right? Look at the reagents that are involved when we're talking about preparation of these gases. Preparation, the reagents involved, the setup. And that is why in Form 1, somebody can ask, in Form 1, this introductory, how is it said? Look at the apparatus. They can actually ask you, like paper 1 that I was marking last year, they were actually asking a student to draw a setup that can be used to prepare a particular gas. And this setup, of course, has got the vessels where the gases react. Then there is a vessel for drying. There is a vessel for collection. Right? So when we talk about gas collection again here, you must know that we have those gases that are soluble in water and those ones which are not soluble in water. Right? Those ones which are soluble in water or which are actually either denser or less dense by air, you should know the method of gas collection. Very important. Am I communicating? Over water is normally used to collect those gases that are actually slightly soluble in water. Hydrogen, oxygen, right? Carbon 2, but not carbon 4, right? Nitrogen, etc. So you must know the methods of gas collection. Each gas that you analyze, know the method of gas collection. And then if you want it dry, you must know the correct drying agent for these gases. And then these drying agents, of course, there are not many. Those ones that we teach you, these ones are obvious. We have concentrated sulfuric 6 acid, all right? And then we have what we call fused calcium chloride, or you can talk about anhydrous calcium what? Chloride. That is normally placed in a U-tube where you pass the gas and then it's dried. And then, of course, we have those gases that are able to react with either fused calcium chloride or concentrated sulfuric acid. Like ammonia, for example, we use calcium oxide. So ensure that you know the drying agent. Very important. Now, having looked at the preparation bit in terms of reagents, methods of gas collection and drying, ensure that you know the confirmatory test. I hope you are writing as you revise, because when you are revising now, you should be having that. What am I going to revise when I talk about gases? The confirmatory test for these gases. How do we confirm? There is the chemical test and the physical test. Am I communicating? Right? Like, for example, if you talk about these two gases, they're normally confusing. Hydrogen and oxygen. How do we confirm them? Right? When we talk about oxygen, we use what we call a glowing splint. Don't confuse that. Not a burning splint. We use what? A glowing splint. A glowing splint is rekindled or it relights a glowing splint. That is oxygen. That is a confirmatory test for oxygen. Hydrogen, we use what we call a burning splint. There's a difference between glowing and burning, isn't it? If you light a splint and you see some fire, right? That is a burning. It's burning, the word burning. But if you put up the fire and then you see it's glowing like charcoal, that is what we call a glowing splint. So for the case of hydrogen, please note that it extinguishes a burning splint with a pop sound. This one you can also be asked how to confirm gases. Carbon dioxide, you use lime water. It forms a white precipitate with what? Lime water. You see that? And we can actually go on to mention each of these 18 gases, how to confirm them. There are those ones which are confirmed using chemicals. Like, for example, carbon dioxide, where we use lime water. That is confirmatory test. Something that is very important that you need to note as far as gas is concerned, we look at the physical properties. Physical properties, we are talking about the color of the gas, talk about the smell of the gas. There are those ones which have, they don't have any smell. They are odorless, colorless and odorless, right? There are others that have an irritating, choking smell, a pungent smell, right? There are those ones that have a specific color, like, for example, nitrogen 4. It is brown in color, or red-brown in color. That one gives a definite color. See, there is one that has a characteristic smell of the rotten egg, hydrogen sulfide. That confirms that particular gas. So you must know the confirmatory test of these gases. Then we have what we call boiling point and the melting point, right? We can actually, especially for the organic bit, the alkanes. Alkanes, we have the first 4 members: methane, ethane, propane, and butane. They are gases. How do you actually, look at their melting point and boiling point? Of course, the trend as the number of carbon atoms, of course, increases. What can you actually talk about the trend in terms of melting and boiling point of these gases? Right? And of course, when you talk about gases, they actually exist in molecular form. There are those ones which are monoatomic gases, especially noble gases. Others are diatomic. Others are triatomic. So when we talk about molecules, when molecules, for example, combine, they actually form. There are those ones that form very strong covalent bond. For example, nitrogen gas, it forms the triple bond. There are those ones that form what we call the weak intermolecular forces. Weak intermolecular forces we have, for example, the van der Waals forces, which are very easy to break. Now, what determines the melting and the boiling point of these compounds, which are molecular? We have those forces. When you see, for example, a gas, let's say, for example, sulfur 4, what makes it, of course, to have very low, boiling point is because of the fact that the molecules are bonded using what we call the van der Waals forces, which are very easy to break, hence low, boiling point. So you need to explain that. The physical properties. Solubility is another factor that is actually seen as physical. Are those ones, of course, which are soluble, right? They're soluble in water. Others, of course, like, for example, the organic gases, they are actually soluble in organic solvents. What are some of the organic solvents? We have, for example, tetrachloromethane, we have methylbenzene, etc. Why are they able to dissolve? Because they are non-polar, form force. Polar solvents dissolves a polar compound. Water can be able to dissolve, some of these, compounds, because water is a polar compound. It will actually dissolve another polar compound. Gases are able to dissolve in non-polar compounds because the fact that the non-polar solvents would actually dissolve the polar compounds. All right. Then we talk about chemical properties that takes a good chunk of the content in these gases. Chemical properties. How does these gases, of course, react with other compounds to form compounds? Then lastly, you look at the uses of these gases. If you do that thorough analysis, that is what we call now octopus techniques of summarizing, notes. because we have quite a number. Like, for example, when you talk about inorganic chemistry, where we have the compounds of sulfur, the compounds of carbon, the compounds of nitrogen, the compounds of chlorine, if you summarize them that way, because we have those gases, of course, in those topics, you cannot go wrong. If you have that, then you are good to go. So industrial chemistry takes 40 marks. Those who wants to eliminate D and E, you can actually study the industrial chemistry and gases where we analyze those compounds. Physical chemistry, D eliminators, elimination of D and E grades. You must ensure that you are well grounded in rates of reaction, radioactivity, electrochemistry, and energy changes. Our director taught you from force. He dissected radioactivity very well. And I want to believe that when you're going down to your schools now, go down to the questions. Look at the content that he gave you. Are you able to see the way the questions are tested? Right? Then when you talk about the reaction rates, electrochemistry, and energy changes, those forms another area. For those of us who wants to eliminate this grade E and D, you must ensure that you actually be well grounded in those topics. I know you will be taught, or you've been taught by your teachers. But again, don't ever miss this opportunity of coming, especially the candidates and all of you. Don't miss coming in August, where we shall now do a thorough job of looking at these questions. Now, we were giving you content, teaching you about the content. Ikifika August, we shall look at the questions properly and then tell me why you cannot get an A and become a doctor. You will become a doctor. You will. I want to meet you in KNH when I'm old. Mwalimu, you taught me. Can you come? I'm a surgeon. I have a problem here, maybe the spinal cord. Now, come. Takushughulikia. Why? Because I taught you chemistry. You have been able to do medicine. You are now a medical doctor. I want you to become a pharmacist so that you can be able to give people drugs. You become resourceful. Right? That is why we are here, to mentor you so that you become what we want you to be. Then lastly, organic chemistry. It's actually, I don't want to repeat because I've already said that. So, in summary, as I conclude, pillars of chemistry. The following areas forms the great pillars of chemistry. I call them the commandments, the 7 commandments of chemistry. For those of us who are talking about chemistry, you cannot do without this. The reactivity series that you learned in Form 1, right? When you talk about reaction of atoms to form compounds, right? We talk about the reactivity series, isn't it? That's one you are taught in Form 1. And even in electrochemistry, right? It is also, we have what we call electrochemical series that actually requires you to have these reactivity series also. You must know the first 20 elements. Am I communicating? Tuko pamoja? Hydrogen, helium, lithium, beryllium, boron, oxygen, nitrogen. Which one? Fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur. Continue. Chlorine, argon, potassium, and then lastly, calcium. You need to have them here at your fingertips, because the chemistry that we are teaching you will be revolving around those elements. We'll have some few from transitional elements, but you must have the 20 elements. Writing balanced chemical equation. This one I've already been emphasized. I don't want to repeat this. A student who writes an equation that is not balanced, you don't earn anything. Ensure that you are able to write the correct balanced chemical equation, and this one requires you to have the knowledge of the valency, know how the atoms, of course, react by employing that knowledge of valency to form compounds, and then of course you are able to write the chemical equation which is very balanced. Of course, you need to state the state symbols. An equation that doesn't have the state symbols, you will actually lose half a mark for that. Industrial chemistry and gases, that one I've already said. Solubility of gases, I've already mentioned. The mole concept and organic chemistry, those ones are the pillars of chemistry. Otherwise, I know time is much spent. We can stay here the whole day. In fact, if I want to actually talk about chemistry, I can talk about chemistry the whole day, from morning to evening. It's only that time cannot allow me. I have a lot that I can actually say, but because of the interest of time, I would want to stop there. Wish you all the best, hoping to meet you in August so that we can be able to dissect, to illuminate, and demystify this chemistry that is giving people headache. God bless you.
Let us appreciate the teacher. In a proper manner, let us appreciate the teacher. Thank you so much, Mwalimu. It's been resourceful to have you here. I want to also thank the student for this period that you've been so patient. Actually, sitting for over 3 hours without any kind of disturbance, you really deserve a pat on your back. You can also appreciate yourself, by the way. We are literally breaking for lunch. I know some of us are also pressed, I know that. We have the washrooms the other side for both boys and girls. So immediately you get out, you can simply walk a little distance, then you get to the washrooms. We only have 30 minutes to have our meals. We have the meals already served, so we are only going to make queues, then we serve our meals, after which we are going to come back to the same hall for the last session. We promise that it's not going to protract. Before long, we'll be done. Otherwise, I also want to believe that you guys are benefiting, right? So we can all move through these exits, but we are going to make two lines. The line for boys and the line for girls as we serve our meals. Have a nice lunch.
Same to you.